Okay, let's see try to find the value of x, right? Here, yeah, we need to do a little bit a construction. Here, you need to join b and d, right? You can join b and d here, right? That's the method come to my mind. Like this way, you can join. Okay, then you know this thing. What the we call normally alternate segment theorem. Alternate segment theorem. Now DC, that means this chord, DC chord, right? Now this is KM is a tangent, no? KDM, this is a tangent. This tangent, what the tangent point, if you make a chord like this, right? That means DC chord. This is draw from the tangent point. This is the tangent, no? KM tangent. From that tangent point, draw a chord like this way. This chord, right? Subtended angle circumference, that means this one is equal to between the angle tangent and the chord. That means if you have a tangent and chord, this chord draw from the tangent point like this way. Now DC, right? This chord subtended angle at circumference is equal to the angle between chord and the tangent like this, right? That means if this is 30, this should be 30. That's the basic idea. If I draw roughly here, right? If you have tangent and this way at tangent point, this one subtended angle like this way, this one subtended angle, this one is equal to this one, these two equal, right? Between tangent and the chord, this angle equal to this chord subtended angle at circumference here like this angle equal to this one, right? This one, that means here should be 30, this should be 30, this should be 30. And then you know what the, if this is 30, this is isosceles triangle, they tell no BC and DC equal, right? So that's why opposite angle of the equal side is equal. This is isosceles triangle. BCD is an isosceles triangle. So these two sides equal. This side opposite angle, this one. This side opposite angle, this one. That means if this is 30, this also must be 30. Right? This is 30. This is the equal side, that that angle, that side, BC side subtended what the angle here. Opposite angle of the BC is this one, this angle. This DC opposite angle is this one. That means these two equal, because these two sides equal. Okay, then now we need to find x, right? Now how to get this angle, right? This angle, that means BCD angle, this one. Again you can use this way, what the 30 plus 30 and plus BCD angle, right, should be equal to 180, right? This is interior angle of triangle. If they ask the reason, you can write like that, interior angle of triangle. So then here will be 60, right? 60 and BCD, right? Then what we can do, this 60 bring to here, so it will be BCD equal 180 minus 60. So here BCD angle will be 120, right? Then we know this is a cyclic quadrilateral. That means ABCD is a cyclic quadrilateral. That means if this is 120, now we got the answer for this one, 120. This should be again 60, because in a cyclic quadrilateral, opposite angle add up to 180, or supplementary, we call normally supplementary. Now in a cyclic quadrilateral, opposite angle add up to 180 or supplementary. That means now if I show you roughly idea here like this way, if you have a cyclic quadrilateral, right, this angle plus this angle, opposite angle must be 180. So 120 plus x should be 180. So you can write it like this way, 120 plus x should be 180, right? Then 120 bring to this side, so that means 180 minus 120. So what the answer for x? It will be 60 degree, right? That's the answer for x.